Good morning to everyone. Glad you guys kind of came out. Obviously, it's Thursday, so a little late in the week to be doing some of these talks. A lot of people I know certainly could be pretty burned out at this point. So to kind of lighten the mood, we are actually going to do a little bit of a bottle giveaway to kind of have a little bit of fun with this. So essentially, this is High West Double Rye Whiskey. You'll see how this is sort of a bit incorporated into the presentation. It's out of Utah, which no one thinks Utah has alcohol, but we do. So essentially, if you tweet a picture of your favorite slide, tag it the proper Twitter way with at S1P and at Solace.com, then you'll, at the very end, we'll pick one of you to actually take this bottle home. So essentially, kind of I came to Solace about 8 months ago. Previously, I was a customer, and I'm responsible for our Pivotal Cloud Foundry and Microservices strategy. And so I kind of said, okay, well, if I'm going to be switching my architecture over to using microservices, these are sort of the attributes that we really want to have as part of this sort of digital transformation. And so essentially, we all want scalability. That's one of the big reasons a lot of people choose to go into microservices architectures. Certainly horizontal scaling, dynamic scaling, and shock absorption can all be a big thing. And actually, shock absorption was a new term to me when I came to Solace. And it really revolves around the idea that, you have irregular bursts of traffic. Let's say that you're a major e-commerce site and it's Black Friday. You're obviously going to have huge spikes in demand versus just a typical day in the middle of, say, July, right? So the ability to sort of deal with shock absorption and have fault tolerance where if something does go wrong, you aren't losing units of work, you can have them retried. You need to certainly have performance, especially where user interaction is sort of dictating your performance. And, if something takes a long time to respond, people kind of give up. They essentially will go to another e-commerce site. They'll use a different thing. Service execution can't exceed planned timing. So I worked on previously a big satellite ground system where we were taking massive amounts of data that we had to do a lot of science algorithms on. And certainly if you had a performance issue, you actually just had to start dumping data, which was against our SLAs. Finally, certainly manageability and security are key as well. So if you kind of aren't getting some of these aspects, certainly your microservices architecture has some flaws in it. So I'm going to tell sort of my journey through using microservices here at Solace, actually with a real story which ties in the whole whiskey thing, right? So earlier in the year, I was actually in Scotland with my wife, and we went to this place in Edinburgh where you could essentially do all these different flights of whiskeys and taste like kind of what you wanted. And so I found this certain whiskey, Dalmore King Alexander III, and thought, I wonder if I can buy this in Utah. That's where I live. And everyone kind of thinks, like I mentioned before, that Utah doesn't have alcohol. We do, just not maybe as much as other places. So essentially, the alcohol, the way that you buy alcohol in Utah is all actually controlled by the state liquor store, which is a state-run government agency. But they do provide two little web applications that I use a lot. One is the online price list. It's every product that's ever been in stock in the state of Utah. And inventory query, where you can actually look up dynamically for a given product, where is it located and how many bottles are in stock. So there I am in Scotland using my Chrome browser on my phone, trying to determine if they had it. And so from an online price list perspective, this kind of gives an example of the kind of data that you get back. Essentially, we've got the product name, we have the price, and we have some other gobbledygook here, which we'll use later. As you can see, though, King Alexander wasn't in the list. Kind of a bummer. What inventory query data looks like is actually a screen that looks very much like this. So this is Dalmore 15-year. It's $136, so a little bit on the pricey side. And these are the 5 stores that carry it, along with the actual quantities that are in stock in the store. So it makes it nice that you can sort of look up exactly what you want before you kind of go through this aimless search all around the city trying to find something. So that's kind of nice. So essentially the outcome was, I wonder if I could sort of build an application or microservices architecture, since I'm responsible for that at Solace, that actually could tell me when it was last in stock, which means I have to take sort of a historical view of inventory, and be notified when it actually comes into stock so that I don't have to sort of weekly or monthly remember, let me go see if they finally have gotten it. To this date, by the way, that was earlier this year, they still don't have it. So essentially, what the high-level architecture really kind of ends up looking like is the way I think a lot of people's architecture looks today, where essentially they sort of have what I would call kind of a legacy on-premise environment. Certainly, from the looks of those web pages, they kind of look like old technology kind of legacy pages. So I kind of make them a bit of my scapegoat here and say it's a legacy environment running on-premise. You might have a GCP cloud provider that you're using. Maybe you're running Pivotal Cloud Foundry because that's where you want to run your microservices. So these little shapes here represent databases and sort of microservices. And then increasingly, a lot of our customers are running in multiple clouds. Maybe they're running their workloads in GCP, but they're wanting to use analytics capabilities in the Amazon cloud. So in this case, I'm going to use Elastic Stack to sort of do analytics on the products that basically all that data that we just saw kind of ingested into Elastic Stack. So I think kind of like most folks, I kind of went out and I searched all through the web to determine, okay, how should I really be building these things? I was new to Pivotal Cloud Foundry. I read a whole lot of different Martin Fowler and different articles on how to properly build these microservices. So I said, okay, I'm going to basically use REST. I'm going to be all in on REST because, heck, even Wikipedia says that microservices should use technology-agnostic protocols like REST. So essentially what we did is I have two microservices here. I have the client, and the client is the piece that actually initially goes and gets the online price list, so that big, long list of all of the products. It's not a REST service, sadly. I'm literally doing screen scraping, and so that business logic circle is actually just screen scraping logic and basically taking that data and making it into a JSON document. From there, I use the Spring REST template to basically send that out over to the inventory service. So for each of those 14,000 products that we've ever had, I essentially do a query against the state database, and more screen scraping activity ensues, and then we're able to invoke a REST endpoint actually that Logstash can have to actually ingest that data down into to be able to do analytics. So this actually all worked, but it had sort of a set of issues that I'm sure a lot of you think are probably pretty obvious. We're at a developers conference, but first issue was, the client, because essentially it's a series of synchronous calls, if there were any performance issues, downtime, upgrades that were occurring to the inventory microservice, happening external to me with the inventory query or a downtime in the Elastic Stack, my client is basically going to really start to have issues processing. It basically can time out and have a whole host of different issues. The next issue was, obviously with Pivotal Cloud Foundry, it kind of gives you the ability to do some amount of service discovery for things that are running within Pivotal Cloud Foundry, but since Elastic Stack was running externally, and in fact, so was the inventory query, how do I write in my application where these endpoints actually are? Sure, I can have external configurations. I could put it into VICAP services as a user-provided service, but nothing really felt all that elegant. Third is, certainly we have a lot of tight coupling here. We've kind of mentally made this decision that the client microservice needs to call the inventory microservice. The inventory microservice needs to send its outputs onto Elastic Stack. But a great example is, what if I wanted that pricing data that actually was coming out of this microservice to go to Elastic Stack as well? Well, now I've got to sort of crack open this microservice, add additional invocations to it. It's not really all that elegant again. And then third, and this was actually my biggest concern for all of this, is since I had no sort of filtering logic in this inventory, my premise was I'm really interested in whiskeys. It's not to say I don't like wine or beer or other things, because I certainly do. But the whole premise of this was I wanted to just deal with whiskeys. So in this, I would have to add sort of content filtering in this microservice to say only whiskey products do I really want to go out and query. And the reason why this was an issue was I was really starting to worry that the state of Utah would think that I was basically going to be part of a denial of service attack, because 14,000 products is kind of a lot of things to be constantly querying from the same IP address within a very small amount of time. So I kind of decided that to stop. This wasn't the right approach to go. Certainly, I do, of course, work for Solace, which is a messaging company, and so I kind of thought, this is really interesting, because I feel like a lot of people kind of make REST about everything, and REST is a great tool to have sort of in your toolbox, but in this case, REST has sort of, I think, become a bit of a hammer in the industry, and certainly not everything is a nail. And so we actually in our product support REST, so I'm not here to sort of just bash REST or make a big deal that you shouldn't be using REST, because it is good for certainly where you have synchronous interactions in your architecture, as well as externally facing APIs. Certainly things like historically, like Swagger has made the description of REST interfaces really, really easy. But it does bring some of the baggage, and I think we've seen some of that as we sort of have gone through the very beginning part of this presentation. First, it brings about blocking. Just like I said before, you have all these sort of synchronous interactions all lined up, so you've got a whole chain of blocking invocations. You have the service coupling problem, where you sort of are inherently saying that these services are all tied together in sort of a serial sort of methodology. And then kind of the whole complex failure scenarios, and is it really, whose responsibility is it to deal with when services are being upgraded and they're down, how long should I wait to retry? Should I start doing exponential backoff? All of these sort of things start to clutter up your microservices, which the whole premise of microservices was to have small in size, single and purpose microservices. So I kind of contend that if you have to write a whole bunch of logic all about how a downstream service could behave in off-nominal scenarios, that it's actually not single and purpose anymore. So the solution, I think, to a lot of this is to think more event-driven. And essentially, all microservices have inputs and outputs. If they didn't have inputs and outputs, they would be pointless services. And so essentially, here's the definition of an event. I stole it certainly from the great source of Wikipedia. And so essentially, it's just an action or occurrence, and your software can choose to recognize it or choose not to recognize it. And so the key is, I think, in that third main bullet is to stop thinking about services invoking services, because you sort of, as a microservice designer, you shouldn't be so opinionated, in my opinion, of what and how these microservices could be sort of orchestrated together. Instead, if you just think about, okay, I'm going to take in a certain type of event and I'm going to produce a certain type of event, well, that event could be picked up by 0 downstream services, it could be picked up by 1, it could be picked up by many services. And so then you don't have all of these sort of having to go back and update your microservices. It's just doing what it was supposed to do. It's taking an event, maybe doing enrichment, maybe it's doing some lookups, some combinations, et cetera, and then it's able to just emit events itself. So essentially, as I put here, what do we emit these events to? Well, certainly messaging, right? So whether that be RabbitMQ, or you could use Kafka, or preferably you use Solace, because we do have a lot of advantages. I'm not going to make this into a sales pitch, but certainly check us out. So if we kind of go back to the online price list data, where I said before there was sort of this garbly-goop. This actually makes up of a topic hierarchy in of itself, right? So A actually stands for spirits, W stands for whiskey, so yes, and then R stands for blends, S is scotch, they have bourbons, et cetera, right? So now we're able to actually do content filtering based off of our topic hierarchy. So in Solace parlance, we basically just apply a topic string as a piece of metadata to a message, and we're able to do millions of topic matches per second, so we're very, very efficient in doing topic matching. So essentially, the better way, and this is actually what I have running today, is essentially we have the same outcome we have the client and we have the inventory provider, but we also have now the Solace messaging for Pivotal Cloud Foundry. So we actually have a tile that you can run and deploy in Pivotal Cloud Foundry. We actually also have purpose-built hardware appliances that could do millions of messages per second guaranteed. We also, as of this week, have a messaging as a service option called Solace Cloud. And Solace Cloud is essentially sort of to compete with the SQSs and SNSs, where you want to be able to make use of messaging, but you don't want to have to stand up the infrastructure yourself. So any of those options really could be used here. Since this is a spring conference and a lot of folks use Pivotal Cloud Foundry, we thought it would be good to show it this way. In fact, we actually, for the demo that you'll see today, this is actually running in PKS, Pivotal Container Service, so in Kubernetes. So essentially, we still have to do the HTTP post to get the online price list. Nothing's changed there. But instead of using the REST template, we can now use Spring JMS template. Coming soon for us, actually, you'll be able to use Spring Cloud Streams to do the same kind of thing as well. But essentially, we can now publish this to a topic called product / in this case, just XYZ, which kind of represents that A for spirits, W for whiskey, S for scotch or single malt. So then what we're able to do is we're able to have this inventory microservice here use a Spring message listen container configured to consume off of this queue. And the reason why we want to use a queue here is actually in Solace land, we sort of have this capability where you can have queues subscribe to topics. So essentially what that allows you to do is this queue is going to consume every spirit and whiskey product that ever comes through. But we're able to now scale this guy up horizontally in a non-exclusive way. So essentially do round-robin load balancing to these different inventory services to have better performance. We still have to do the invoking of the inventory query and do that business logic related to screen scraping. But now we'll republish the outcome events, those inventory pieces of data, off to the Solace messaging provider here. But we now use a new prefix. We use the inventory prefix because in our initial design, right, we only wanted the things to go to Elk or Elasticstack to be those inventory components. And so we in Solace, we support the greater than wildcard so that you don't have to sort of explicitly state all of the different options. I don't even know how many different whiskey products there were. So by being able to use wildcards, this is made very, very simple. So then, to get the data into Elasticstack, we have a component in Solace called a REST delivery point. And what that really is it's an integration mechanism that allows you to essentially have a REST delivery point consume off of a queue, just like that microservice, but basically do a REST post to any REST service, right? So essentially, we do the REST post into Elasticstack, and now we've completed that full cycle that we did before, but with a lot of benefits because we now are only consuming and doing inventory queries on whiskey products. The inventory service has no notion that Elasticstack even exists. The client, this product data could actually just be added to the queue subscription here, and now his data is going into Elasticstack. And ultimately, even the client and the inventory, they don't even know about the existence of each other. Simply consuming, this guy's generating events from an outside entity, and this guy's simply taking an event and then producing new events. So that was kind of the premise of why I had said very early on to sort of think more about the generating and consuming events versus thinking about actually doing service invocations. So one of the things that we realized, in fact, my boss realized this very quickly from a price perspective, was that while all of this functionally works, the link here between cloud providers can be pretty expensive. Turns out that some cloud providers, the amount of, it's kind of free to put your data into the cloud, but you pay money to have data go out of the cloud. And that cost can certainly add up over time. In fact, Yeah, it wasn't a good month after I had run this for the entire month, and kind of how much data I was kind of putting over into Elastic Stack. So the key to this sort of picture is that, you know, we are actually supporting kind of a whole bunch of different options here. You know, we have kind of a legacy to cloud data movement use case. We're doing cloud to cloud data movement. We're also supporting a platform as a service here, so our microservices within Pivotal Cloud Foundry are able to make use of messaging. And the key, of course, is so Solace can actually be deployed in all of the clouds as well as on on-prem environments. And strategically here, what we are able to do is actually fix the network cost problem by using a bridge. And a bridge is really the Solace terminology for being able to sort of connect up multiple of our brokers together and kind of do data federation. But we also provide out-of-the-box compression of those messages. So in the case of my pieces of data, which were JSON documents, we actually have statistics that you can keep track of in real time as to how much of what is basically the compression ratio of the data. And so we are actually saving about 80% on our bandwidth by just being able to do compression. So of course, there's a cost calculation any organization would actually do of, okay, well, what's the cost to run Solace versus what's the cost of that network piece? But it does give you options and flexibility that otherwise you wouldn't really have. So really, I think this is sort of the summary for the entire deck here, is that you know, there are a lot of benefits to sort of thinking more event-driven, especially with microservices. By using messaging technology, and messaging has been around for obviously a whole long time. Messaging has helped with distributed systems for decades. And really, microservices are sort of creating pretty complex distributed systems where you need high amounts of throughput, you need high performance, you need guaranteed message delivery, and all of these things is really what messaging excels in, right? So the benefits, as we saw, I think, includes, you know, basically limited service-to-service coupling. You know, you're always going to have data-level coupling. You know, it's just sort of the reality of how things are, but you shouldn't necessarily sort of, again, have that opinion of how should your services sort of be orchestrated and choreographed together. That's where the whole event-driven architecture kind of comes into play. Additionally, you know, you can have no impact service upgrades because as a service, as a microservice is being upgraded, the messaging tier, because you chose event-driven, really is responsible for, it's really responsible for holding on to those messages so that when the service comes back up after an upgrade, it's able to process all the data that it had missed in the meantime. It's easy to create new services. I actually did this entire architecture in about 3 days, so it's not like, in fact, most of the work was probably getting Pivotal Cloud Foundry installed the first time, but once I had that, it was really easy to create Spring Boot applications, use the built-in features of Spring in order to basically link up these different microservices. And coming soon, as I mentioned, right, once we have Spring Cloud Streams, it'll be even easier. We're much more resilient to service failures because we do have that sort of shock absorption mechanism in the middle of our system where we can write data and persist it and then kind of come back to it after the service comes back up. It's more resource efficient because, you know, if you kind of think of sort of a chain of invocations, if you're basically only as good as your weakest link, so you kind of have to scale all of the services in front of that in order to scale and compensate for that one misbehaving downstream service, whereas this allows you to sort of, in a very fine-grained, scale up individual microservices much easier. But I think there are some challenges. I mean, certainly when we talk to a lot of our customers, which, you know, are actually a fair amount of Fortune 500 companies, they really struggle because I think in a lot of ways, some developers really think in a synchronous way. Everything to them is sort of a function call that should return almost immediately, but certainly with distributed systems, that isn't always the case. And then being able to do correlation can be a challenge if you're having to sort of take multiple disparate events and have to sort of tie them all together in order to produce a new piece of data. There's certainly, you know, the ability to do correlation IDs and all of those kind of things, but you got to kind of think through the problem a bit. So that is really sort of what I wanted to talk to you guys all about today. You know, certainly come talk to us at our booth booth number 6. I know it's getting late, and we all are probably going to be catching some flights this afternoon, but talk to us about event-driven architecture. Talk to us about Spring Cloud Streams and what we're going to be doing in that, in our binder to support that. Talk to us about Pivotal Cloud Foundry if you're a Pivotal Cloud Foundry customer. Definitely go to cloud.solace.com/sign up if you want to try out our messaging as a service offering for free. You can actually do 1 million messages a month for free, and no charge. We don't even take your credit card. And certainly ask us how we compare to Kafka or Rabbit or ActiveMQ or any of the sort of legacy technology providers that are out there. So that is the conclusion of my presentation. Hopefully, someone on the Solace team has been looking at the tweets that you guys and pictures so that I can give away this bottle of whiskey. So someone from the Solace team want to come up and announce who had a good picture? All right, come on up, Amy. Enjoy, thank you. So I think we have a couple of minutes if we have any questions in the room for anything that I presented. If not, then certainly come and visit us at the Solace booth. Sure.
What was the reason for deploying Solace software in PCF into the Elastic Runtime rather than on static VMs?
So actually, Solace isn't deployed in the Elastic Runtime. It's actually deployed on VMs, all managed by Bosch. So essentially, if you went to PivNet, downloaded the tile, essentially it runs a service broker in the Elastic Runtime, but it actually, depending on what options you picked in the marketplace, deploys those on just the infrastructure as a service that Pivotal Cloud Foundry is running on. Sure, so he asked what the rationale was for deploying the Solace messaging capability in the Elastic Runtime instead of just as VMs, right?
Yes, and I assume that was the case because to use the service from outside of PCF, you need to create routes.
Yeah, so he's asking about if you need to sort of access the Solace service from outside of PCF, how we sort of do that. So because everything is sort of managed by Bosch and it's all running within the same IaaS, it's getting IP addresses and stuff that is actually local to the sort of internal PCF network. And so what we actually have done at Solace is we utilize the TCP routes feature of Cloud Foundry. So essentially, when you go into our ops manager and into the ops manager and you can configure what ports, whether it be AMQP or MQTT, et cetera, that you want accessible from outside of PCF. You basically just say yes or no to those ports, and essentially we dynamically create the routes that are addressable on the outside and map them into our internal ports and IP addresses. So we do support fully whether you're wanting to access Solace from within PCF or you're wanting to access it from outside of PCF. And that actually is a great use case and capability we provide because we do support MQTT for IoT use cases. We've had a lot of customers that have, for instance, millions of connected cars access Solace's service and then have microservices running in PCF that can consume the data via AMQP or JMS or whatever the protocol that you choose. So I think I'm out of time. I'm getting the rope here. So thanks, guys. If you have any other questions, come to the Solace booth.